Hello there. Today we'll be tackling the first problem in the legendary book Principles of Mathematical Analysis by Walter Rudin. So here we have our little problem. We may analyze this problem first. We see that we have some conditions. 1. R is rational and R is non-zero. And 2. X is irrational. So our goals are to prove that 1. R plus X is irrational and 2. R times X is also rational. So this is a very intuitive proposition and should be relatively easy to prove. When we see that, want to prove that something is irrational, we always think back to the proof, for many of us, the first proof that we have done, which is the proof that the square root of 2 is irrational. So how do we do that? Well, first, what does it mean when something is rational? It means that we can say that R is equal to the fraction P over Q for some PQ members of the set of integers, or simply the integers, and the greatest common divisor of them is 1, which means that this fraction can't be simplified, and Q is non-zero since it's the divisor. So to prove that R plus X is irrational, we must assume that it is rational first, to use the proof by contradiction. And so we assume that R plus X is rational, i.e. R plus X is equal to Mn for some integers Mn, and just like we've done before, they're co-prime, which is another word for them having the greatest common divisor being 1, and N is non-zero. So we have said that R is equal to P over Q, and we can do that because it's rational, right? So let's write this out. And at this point, what to do should be fairly obvious if you have actually taken the prerequisites to reading baby Rudin. So we have X is equal to M over N minus P over Q, which is equal to MQ minus MP over NQ, which is a rational number. And so we have that X is a rational number. But this contradicts our condition. Let's take a look at the previous page. We have a condition that, look, R should be irrational, so it's not rational. And here we have a contradiction. And as a previous teacher of mine liked to write it, contradiction factorial. And so we obtain that R plus X is irrational. The proof for R times X is irrational should be fairly similar to this one, and it's left as an exercise within an exercise. And we are done.